Hello. So this is the first video we're going to try doing for Algebra 2 online learning for this week. And in these videos for this week, there's going to be, I think, probably 3 videos you'll have to watch. I'm trying to keep the videos shorter, so like bits of the lesson rather than doing the whole thing in one go, so that if you're watching this, you can watch just one video, focus on that piece, and then like pace yourself through it rather than having to watch the whole thing at once. I will post all the videos together, so if you want to, you can watch the whole thing together. Um, but it's really up to you, and I'm trying to make it more convenient so that you can go around to it. It also makes it easier for you to find things later on, so if you want to refer back, you'll know which video to go to based on what you want review on. And so really, this is a new chapter we're starting on trigonometry, and the way to think about what we're doing is kind of connecting the bridge between the trigonometry you learned in geometry into what you'll start using trigonometric functions to do. And it's kind of like moving into this like whole field of trigonometry. So the field of trigonometry is used a lot for things that happen on cycles. So things like daylight, things like rainfall, tides, stuff that repeats, right, in seasons or in years or in months, things that happen over and over again the same way, usually. Um, it was kind of invented a lot when people were looking at astronomy, so looking at stars and planets and trying to measure distances, but they're looking at it from angles, so they have this idea of angles, but also side lengths and distances. And so this is a way to connect an angle into a side length. So a lot of time, especially, it's used for distance measuring. So thinking about if you wanted to measure the distance from, say, Cupertino to Seattle, to measure that distance, no one's going to take a tape measure and measure that distance out in real life. I mean, that could be an interesting thing to do, but probably not what a lot of people want to do. But you can calculate that distance using other methods that then you can use math to calculate rather than having to physically measure out that distance. So we're going to start off with right triangles, but eventually move into what we can do with angles and circles. And that's the main focus of trig for you next year in pre-calculus or in applied math. And this year, we're really going to focus on reviewing that right triangle stuff and then starting to make that connection into circles and angles and a more general version of this. So starting off with right triangles, we have right triangles are triangles that have a right angle in them. And so here's a right angle in this triangle. That's what tells us to the right triangle. We have 3 sides, and we're going to label one of the angles on here. And it's labeled with this symbol that looks like a 0 with a line through it. This is the Greek letter theta. And it means it's a variable that's used for angles. Just like how we use the variable x a lot in equations when we're solving for numbers, theta is like the default variable we use for angles. You can use any other variable you want. You could say an angle is x or y or z or c or a or b, whatever you want. But by default, people usually use theta for an angle variable, just like how they by default use x as a number variable. So that's all this is saying. It's an angle. We don't know what measurement that angle is. It could be 30 degrees. It could be 25 degrees. It could be 40 degrees. It's some angle. We can label the sides on the triangle based on this angle. So the side that's opposite the 90-degree angle, the longest side, that's the hypotenuse. But then we have 2 other sides, and these are the legs of the triangle. But to figure out which leg is which, we label them based on the angle. So if I look at the angle and I go across from it, so the opposite side, that's the opposite side. And the one that's touching it, that's next to it, is the adjacent side. So you want to get careful about labeling these sides, because a lot of this is going to depend on which side is opposite and which side is adjacent. Just remember, the side that's touching the angle, that's the adjacent side. So the hypotenuse and the adjacent side make the angle. The side that's not touching it at all, that's the opposite side. From this, we can think about ratios of these sides. So ratios of fractions, so basically taking one of the sides, like taking the opposite side, and then dividing it by the hypotenuse. That's a ratio of two side lengths. And we give it a special name. This opposite over hypotenuse is called the sine. So sine is opposite side divided by hypotenuse. The cosine is the adjacent side divided by the hypotenuse. And the tangent is the opposite side divided by the adjacent side. So we're kind of going through each of those three sides, substituting them out, like which fraction they go into, but we kind of covered different variations of them. We have short forms for writing these words out. So sine is usually written sin, and because we're saying opposite and then we're saying adjacent later on, opposite and adjacent depend on where the angle is, right? I could draw another right triangle, right, the same one, but now if I put theta up there, this is still the hypotenuse, but the adjacent side is this side now because that's the one that's touching it. And the opposite side is the one on the bottom because that's the one that isn't touching. So opposite and adjacent can move around based on where the angle is. And so because of that, all these ratios depend on which angle you're talking about. If you're talking about this angle, then the adjacent is on the bottom, the opposite is on the side. But if you're talking about that angle, then adjacent is on the side, opposite is below. So we always put the angle next to it, and then we'll say sine is opposite over hypotenuse. The cosine, that's cos, that's adjacent over hypotenuse. And tangent is opposite over adjacent. So when you're writing these, always remember to write the three-letter abbreviations, sin, cos, or tan, and which angle you're talking about, and then you do the fraction. You can't just have sine by itself because it's a ratio, but ratio of what? And so you need to tell me which angle it's referring to. Then you have three more ratios, and these are called reciprocals because they take these fractions that we have, these three fractions, and we're going to reciprocate them, flip them around, make the numerator the denominator the numerator. So cosecant, that's the reciprocal of sine. The way we write that is say it's 1 divided by sine. And so that means it's the hypotenuse over the opposite. And that's cosecant, which is CSC. Secant is 1 over the cosine, or hypotenuse over adjacent. And that's SEC. And then cotangent is 1 over the tangent. So that means it's adjacent over opposite. And that's written as COT. So then you get 6 ratios. We have 3 main ones and then 3 more that are reciprocals of the first 3. So let's try using these. So in this example, we have a right triangle given to us. We are told what the angle is, and we need to find the 6 ratios. So before we start finding ratios, we want to know all the sides. I have 5 as one leg, 12 as the other leg. I don't know how big the hypotenuse is yet. But I know that right triangles follow the Pythagorean theorem. So if something is a right triangle, then its 3 sides follow a certain pattern. The hypotenuse squared equals one of the legs squared plus another leg squared. So in this case, the hypotenuse squared is 5 squared plus 12 squared. So when I solve that, I get 25 plus 144, which is 169. And to find the hypotenuse, I take the square root of 169, which is 13. So I know the hypotenuse is 13. Now I need to figure out which side is opposite and which side is adjacent. If I look at the angle, the adjacent side is the one that's touching it. So the 5, that's adjacent. And that means the 12 is the opposite. Now I'm ready to write the ratios. So I know sine is opposite over hypotenuse. So that's 12 over 13. Cosine is adjacent over hypotenuse. So that's 5 over 13. And tangent is opposite over adjacent. And so that's 12 over 13. The reciprocal ones, cosecant, I take hypotenuse over opposite. So that would be 13 over 12. Notice that it's just a reciprocal of 12 over 13. Secant would be adjacent over hypotenuse over adjacent. So that's 13 over 5, which again, reciprocal of 5 over 13. And cotangent is adjacent over opposite, which would be 13 over 12. Not 13 over 12, and not 12. I messed up my tangent and cotangent. Tangent is opposite 12 over adjacent, which is 5. And cotangent is adjacent 5 over opposite 12. Again, reciprocals. And then you get your 6 ratios from that. So that's one kind of problem where you have a right triangle given to you, we're just trying to find ratios. Often, though, we don't have a right triangle, and what we're trying to make the switch to is starting out from triangles, but then moving into angles or circles generally. And so we're going to do this other problem. So this one says we have a right triangle. So we have some right triangle, and there's a theta in it, so I'm just going to pick theta and put that in here. And we know that sine of theta is 3 over 11. We want to find the other ratios. So we want to find cosine, we want to find tangent, cosecant, secant, and cotangent. So I know that the sine is 3 over 11, and I know that's the opposite over the hypotenuse, which means the opposite side could be 3, and the hypotenuse could be 11. It could also mean that the opposite is 6, and the hypotenuse is 22. Because opposite over hypotenuse would be 6 over 22, I reduce that fraction, I get 3 over 11. So that's what I mean by saying that we're generalizing this now. It's not fixed to this one triangle in particular. There's a lot of triangles that will fit this. But for simplicity, we're just going to pick the 3 and 11, because it still works out that it's going to be 3 and 11 in the end. Even if I make this 6 and 22, it reduces back down to 3 over 11. So it's simplest to just use the ratio given to me. So I know that 3 and 11, those are two of the sides. This side I still need. That's the adjacent side. So I can use the Pythagorean theorem. I know that 11 squared is 3 squared plus the adjacent squared. So that's 121 is 9 plus adjacent squared. Adjacent squared is 112. And so the adjacent side is square root of 112, which is about 4 root 7. So I can now use those sides to do all the other ratios. So cosine is adjacent over hypotenuse. So that's 4 root 7 over 11. Tangent is opposite over adjacent. So that's 3 over 4 root 7. Cosecant is the reciprocal of sine. So that's 11 over 3. Secant is reciprocal of cosine. So 11 over 4 root 7. And cotangent is the reciprocal of tangent, so 4 root 7 over 3. So that's the end of this first video. This is just the introduction to looking at the 6 trig ratios and using them in right triangles, either from a triangle given to you or from a triangle that you make yourself. Hopefully this was useful to start off with thinking about right triangle trigonometry, and helped you remember stuff from last year as well, where you started looking at this. So there are going to be, I think, 2 more videos. I'm going to look at special angles and triangles, and then we'll do some word problems with this. So yeah, 2 more videos for this week. I'll post all of them up together, so you'll have those to watch after this. See you in the next one.